Hi everybody, in this video we're going to be talking about ratios. So a ratio is basically the communication of a amount in relationship to another amount. So that's kind of a broad definition, but an example of this might be if you were working with a group of kids and there were slightly more girls than boys. If you counted them up and realized that for every 3 boys there were 4 girls, you could say that the ratio of boys to girls is either 3 to 4 written like this, 3 to 4 written like this, or you can also write it as a fraction. So the reason why you can write it as a fraction is because the ratio of 3 boys to 4 girls means that you have 3/4 of a boy for every girl. So obviously in the case of like boys and girls, you wouldn't have a fraction of a person. But that's basically what the fraction means. And it's really useful because all of the ways that we can multiply or find equivalent fractions applies when you're working with ratios. So a ratio basically describes a relationship between 2 amounts, and the bottom number of a ratio may or may not represent a whole amount. So in this case, the bottom number of our ratio represented the number of girls, and the top number represented the number of boys. So this is an example of a part-to-part ratio. You could have also written a ratio of girls to boys as being 4/3, or you could use the semicolon or the word 2 if you wanted to, and that would also be a part-to-part ratio. But you can also have part-to-whole ratios, like for example, if we use the same situation, well, if you have 3 boys for every 4 girls, well, that means you have 7 kids total. So you could do a ratio of boys to all, and that would be 3/7. Or you could have done a ratio of all to girls, and that would have been 7/4. So there's lots of different ratios you can write to represent the same information. But the basic idea is that you will compare 2 different amounts. It may be part to part, like boys to girls, or it could be part to whole or whole to part, where you're taking the total amount and comparing it to part of the amount. So some of the applications of ratios are things like the amount of money you make per hour. So the word per means for every. And so if you make $20 per hour, well, that just means that the ratio of money you make to the amount of time you work is 20/1. Because for every $20 you make, that means that you worked 1 hour. Or you could also express it as the ratio of hours you work to the amount of money you make as being 1/20. So it really depends on which ratio you're describing. So this would be like money per hour, which is usually the way we write it. But you could also think about it as the number of hours per dollar. And this makes sense that it would be 1/20th because you're basically working 1/20th of an hour for every dollar that you make. You can also have things like miles per gallon, or like the instructions when you're making lemonade might say for every scoop of lemonade powder, add 2 cups of water. And even things like percentages and fractions are technically ratios because a percentage is saying that out of the total number of questions I got on the test, or 100%, I got 95 of them correct. So this would be like the ratio of correctly answered questions to the total number of questions. Same thing with fractions. If you said that you ate a half of an apple, you could think about this as being a ratio because your apple has 2 parts in the whole and you ate one of them. So all of these situations are applications of ratios in real life. And basically, anytime that you have a relationship between 2 amounts, like it's $25 for every ticket, or you have 2 teaspoons of salt for every 5 cups of flour, or basically any relationship like that can be expressed as a ratio. And we say that ratios are equivalent to each other if the fraction representation of the ratios are equal to each other. So for example, if you were painting something and a certain shade of pink requires a mixture of 5 pints of white paint to 2 pints of red paint. So maybe I might say that the ratio of white paint to red paint equals 5/2. You could also say that the ratio of red paint to white paint equals 2/5. Both of those ratios would communicate the same information. But there's lots of ratios that are equivalent to this, because I could do 5 pints of white paint to 2 pints of red paint, but I could also do 5 cups of white paint to 2 cups of red paint, because the balance between the two colors is still the same. Or you could even do 5 tablespoons of white paint and 2 tablespoons of red paint. Or you could even do other numbers. Like, for example, you could say, I'm going to do 10 tablespoons of white paint and 4 tablespoons of red paint, because that fraction is equivalent to the fraction 5/2. Or you might say, I'm going to do 25 pints of white paint to 10 pints of red paint. So basically any fraction that's equivalent to your ratio, or the fraction form of your ratio, will represent the same relationship between the two amounts. And usually we will write ratios in reduced form. So this one was the reduced form, because if you look at it in a fraction sense, you can't reduce it any further. And so usually we'll represent ratios in reduced form, but sometimes they may not be. So that's what you need to know about ratios. If you have any questions, let me know.